Welcome to lesson 59. We're going to practice expressing inequalities. So here are the things to look out for as I'm working through the problem. Watch how I translate a word problem into that inequality. Think about what I'm thinking about and how I change the words into an actual number sentence. Look to see how I solve a multi-step inequality in that ax plus b is either greater than or less than c form. Watch how I represent that inequality on a number line, so I graph it. And finally, how I show that I understand the solution to an inequality problem in the context of that situation. In this lesson, we're going to start working with inequalities. Inequalities are very different than equations. So for example, we've done a lot of these, ax plus b equals c, and those represent equations. But in this context, we're going to have something that is not equal. So it's going to be an inequality. Meaning we might have something that looks like ax plus b is greater than c, or ax plus b might be less than c. So they're not going to be equal to each other. So let's look at this problem together, and we're going to learn a ton more about different symbols and how to represent them. Okay, you are planning a party for a group of friends. The cost of the party will be $30 to rent the room and X amount for the DJ. So we have no idea how much the DJ is going to cost. And you have a budget of $75. Write an inequality to represent how much you can spend on the DJ. All right, so our unknown is pretty simple. It's our DJ. That's going to be our X. We don't know how much that is. But whatever the DJ is, we're going to have to spend an extra $30 to rent the room. So here's our DJ. Here's the rental. And all you have is $75. That's your budget. Now, let's think for a minute. Can you spend more money than you have in your pocket? For this context problem, no, you do not want what your expenses are, this part, to be more than $75. That's not what we want for the context of this problem. So we cannot say, could it be equal? Yes, you can spend exactly $75, but you cannot spend more than $75. You won't have enough. So we're going to use a different symbol. We're going to say this expression has to be greater than or equal. So that's a very special symbol. It's like a combination. It's using this symbol plus an equal sign. They get put together and we have it like this. So this means greater than or equal. Okay? So $75 is greater than or equal to everything you spend, X plus 30. So right over here we have our inequality. We've written it out. So hit pause for a second so you can jot this down. And I'm going to just try to push our thinking a little bit and think, how much can we spend up to for this DJ? How can we figure this out? The great thing about inequalities is we can kind of solve them the same way we did equations. This is a one-step equation, one-step inequality. So I can get rid of my constant first, turn it into a zero pair, and say X has to be less than or equal to $45. So I can spend less than $45, or I can spend exactly $45, but I cannot spend more than $45. If I do spend more than $45, I won't have enough money to pay the DJ. All right, Math Marbles, hit pause so you can jot this one down into your notes. We're still playing with the idea of inequalities and what they mean. So here's a deceptively simple problem that's going to push our thinking. Roberto has $20. He bought a soccer ball for $M, and now he has less than $5. Write an inequality to represent the situation. So he has 20. He spends M, and he ends up with less than $5. So 20 minus M has to be less than $5. So this still might be something we're processing and trying to understand, well, what does this even mean? So let's think about when this will be true on a number sentence. And we're going to just randomly pick some numbers. They are going to be greater than 0 because we can't buy a soccer ball for -$. And let's go all the way to when he can spend $20. Why? Because if he spends all $20, how much would he have left? Well, if he has $20 and he spends $20, he'd have $0 left. So this would be true. Okay, so what about if he spends in the middle? What if he spends $10? 20 minus 10, he would have $10. Is $10 less than 5? Nope, that is not a true statement. So he has to definitely spend more than $10. He's going to spend more than 10, but up to $20. So somewhere in this range. So why don't we try a number kind of in the middle? Let's say 15. So he has $20. He spends 15 on the ball. He has $5 left. Is $5 less than $5? Can $5 be less than $5? No. So this is telling us more information. Means that he definitely spent more than $15. What if he spent $15.20? I'm going to try that. $15.20. He would have how much left in his pocket? $4.80. Is that less than $5? Yes. So this works. So what if he spent $18? So he has $20, he spends $18, he has $2 left. So yes, this works. So what an inequality tells me is he can spend any amount as long as it's greater than 15. So that is how we can use some of our logic to figure out what could M be. And that's just telling me, if this is my expression, M is greater than 15. It could be any value as long as it's greater than 15. And that's what inequalities do, because it can be a bunch of numbers. It's not an equation where only one number makes it true. In an inequality, we can have multiple values that can make our statement true. So we're going to hit pause there, but we've written our inequality using the clues in the sentence. 20 minus m is less than 5. And we can start thinking about our number line to figure out, well, what numbers would make that true? All right, Math Marbles, let's hit pause so you can jot this down, and we're going to get some more practice with inequalities today.